All right, so I think I'm rolling here. You guys ready to keep on blabbering away? No, wait, I guess I'm the one that blabbers away. I guess you guys are the unfortunate victims. So I want to talk about polymers, and what I'll hopefully establish to you is that the molecules of living things, carbohydrates, proteins, nucleic acids, are polymers, and all of them are what we call modular. So we'll learn about what that means. So organic molecules in plastics are theoretically limitless in their size. So here's some plastic getting gooped out. And if they are theoretically limitless, they are polymers. So consider the following. I get my little pen here. I've got a carbon atom. It's got 4 hydrogens on it. If I was just doing a whiteboard drawing here and I wanted to take my methane and turn it into an ethane, what would I do? Add what? A carbon. What do you think? Why not? So I'll add a carbon. Here's a carbon. And the carbon has 4 bonds. So I'll put hydrogen all around all the other 4 bonds. And now I've got ethane. Yeah? And if I want to make propane out of my ethane, what do? Add another carbon in the same way. So I'll erase this hydrogen. I'll put on a carbon. And I'll just keep going. All right? I'm just working on a board here. But how long could I do this? 12? What do you think? Why not 13? I'm going to see if I can do 13. 4, 5, 6, 7, 8, 9, 10, 11, 12. Do I have to stop? As long as I'm just drawing on a board, I don't have to stop. I think there is something about 12 in terms of carbon in fats in biological systems, although in biological systems they're also not limited. But as far as this is concerned, I can do this until the cows come home, right? I could do this all day. And as it turns out, the chemistry this is what's called polyethylene, right? Have you guys heard of polyethylene? Raise your hand if you've heard of polyethylene. Have you heard of polyvinyl chloride? PVC. Have you guys heard of PVC pipe? I take every other one of these hydrogens and I replace it with a chlorine atom. What about polypropylene? I take off all the chlorines and I put on a methyl group. Right? So again, whichever of these I'm making, right, as long as I keep going, right, polyethylene is not 12 carbons long. It's not 13 carbons long. It's thousands of carbons long. How many thousands? Well, the answer isn't really given, right? It could be 2,000. It could be 500. It could be 5,000. Right? But if it's 5,000, there's no reason it can't be 5,002 or 5,004 or whatever. Is that you understand? So in other words, they are theoretically limitless. The big concept, you guys do not need to know about plastics in this class. I'm describing this as an example, okay? And the example, I'm using it for the purpose of explaining to you what I mean by a polymer and to give you guys the idea of what a limitless molecule, a theoretically limitless molecule is. Is it really infinite in size? the molecule itself isn't really infinite, yeah? Right? Because if it was infinitely large, it would take up the size of the universe, yeah? If you have a molecule whose size is infinity, it is the size of the universe, yeah? It would fill up the universe. So it's not really infinite, but there's no upper limit on how big the molecule is. Does that make sense? There's always room for one more, okay? So I have a couple more examples to get that idea. All right, so, and again, the reason the idea matters is because carbohydrates, lipids, proteins, and nucleic acids are modular, and carbohydrates, proteins, and nucleic acids are polymers, okay? They are theoretically infinite in their length, okay? So, modular housing means it's made out of interchangeable parts, yeah? You can take off, this is a house inside a warehouse, yeah, on display. And you can take your wad of cash, give it to somebody, and they'll put this house onto the back of a truck and then drive it to your property and then drop it down there, and then you can go live in it, yeah? And if you want the deluxe model, they'll take off this front door and they'll put on the jumbo front door with the bells and whistles, yeah? Right? Modular means you can take the parts and interchange them. Can you think of other things that have interchangeable parts besides these houses? Cars, definitely. I can take off my lame wheels and put on the sweet wheels, and I can have the dealer do it, or I can buy the car and then take it to a shop and they'll put on the fancy wheels there, yeah? And if I want to get the spoiler on the back, then I can get the spoiler on the back. And if I want, am I making sense here? Right? And if I want, and frankly, if the manufacturer wants to take the same chassis and put an SUV on top of it, they can do that. And if they want to put the sedan on it, they can usually do that too. Yeah? So what about freight trains? Are they modular? They are modular, and they are really my best example, so I'll take a second to talk about them. How long is a freight train? So it's certainly not infinite, right? At some point, the train is going to be too darn big, right? But whether it's 50 cars or 51 or 55, you could probably sneak a 56th car onto it, yeah? Does that make sense? Right? So there's no real hard set, forget about it, upper limit to the length of that train, right? And the cars are interchangeable, right? I can take off some cars and put on some other cars. You guys know why that is? The reason is because the cars are built to link together and be unlinked very easily, yeah? So, how do we link together two rail cars? Maybe I drew these cars a little too close together. How do they get linked together? Somebody said pin. Who was that? Is that you, Mike? Pin. Is that true? A pin, what else besides a pin? A hook, right? Well, the hook, pin or hook, what does the hook fit? A hole, yeah? So you need a hole on one side and you need a pin on the other. And the pin or the hook or whatever it is goes in the hole, yeah? So this car on the left has a hook on its right end. What does it have on its left end? A hole. And the one with the hole on the left end, what does it have on its right end? It's got a hook, right? And so as long as you put a hook on one end and a hole on the other, you can add on or take off rail cars. Does that make sense? Quite easily. You guys with me? Okay. And again, if you want to, you can change the characteristics of your train by the cars you put on it. You put a bunch of refrigerator cars in there, and you can have a bunch of stuff to take to the grocery store, yeah? You put your lumber cars on it, you can take your train up to Maine to get a bunch of trees, right, to bring lumber to make furniture or houses or whatever. And if you have a bunch of oil cars, you could take it to Texas and have it get filled with oil so that we could drive our cars around, yeah? Does that make sense? Right? So we can change the characteristics of the train based on the kinds of cars we have. You agree? Okie doke. So can you think of other things that are modular? I always think of Legos, yeah? What do you think? How are Legos similar to train cars in the way I've described the train cars? Pins on top and holes on the bottom for every Lego piece, yeah? And that way you can take the Lego pieces and assemble your castle or your office building or your skyscraper or your whatever you want to build out of Legos from the same set of pieces, yeah? Does that make sense? The number of things you can build out of Legos is virtually limitless, right? Because the parts are interchangeable, and they're interchangeable because they all have the bumps on the top and the holes on the bottom, yeah? Guys with me? All right, so these are all things that are examples to get the idea of how we assemble things and how we take them apart and how they're modular and how we can generate variety from a limitless or from a limited number of kinds of pieces. You guys with me here? All right, so now we're not talking about Legos or rail cars. We're talking about molecules of living things. Molecules of humans, molecules of microbes. Those molecules can be assembled by, instead of rings and pins, functional groups. OH groups, hydroxyl groups, and H groups, hydrogen atoms, yeah? Those two link together, and what do they form? Water, H2O. And as a result, the covalent bond holding the OH group and the covalent bond holding the hydrogen atom on this monomer are linked together, and now this group of 1, 2, 3, 4 molecules has an extra molecule added onto it in the same way that we add on an extra rail car. You guys got that? Okay. So this is an anabolic reaction. We're building a big molecule from smaller pieces, yeah? You guys with me? Okay. We call this process dehydration synthesis. Does that name make sense? The water used to be part of the molecules, but the water has formed into liquid and is now can flow away and can be separated from the stuff itself, right? So we have, you could say we have dehydrated the molecule, yeah? That was previously hydrated, had water on it. And that process is reversible. If we want to break a molecule down, we can use water to do that, right? Water attacks this covalent bond holding these two little green dots together, and those green dots, which are monomers, are separated, and the H2O is now an OH functional group and an H atom, yeah? Guys with me? And we call that hydrolysis. So, dehydration, hydrolysis, what does the hydro mean? Water. What about the suffix lysis? Any idea? Yeah, so the word lysis is a word you should know. So I'll write it here, lysis, to break, burst, cut, pop. All those are ways to use the word lysis, yeah? You ever heard of analysis? Right? Analysis is where you analyze something, you break it apart and study the pieces to understand it, yeah? Usually it's a concept. You analyze a concept by breaking that complex concept into smaller, simpler concepts and then understanding the big picture from the small pieces. You understand? All right. All right, so we'll use the word lysis a lot of the times in the class, so it's worth knowing now. All right, metabolism. So, going back to this picture, right? Building stuff up by dehydration synthesis, breaking stuff down by hydrolysis. This is what your body does all the time, right? When does your body do hydrolysis? And where in your body does that happen? Where does your body do hydrolysis? The stomach. Why would your body do hydrolysis in the stomach? You're breaking down food. You're eating a delicious Super Bowl cheeseburger, yeah? And as you eat it, all the little pieces get down by acids and enzymes in your stomach, yeah? What happens to those pieces? Well, for me, those pieces of delicious burger get rearranged into ever more substantial meat, generally around the waistline, yeah? Does that make sense? That process is anabolic, right? When I build up paunch onto myself, right, I'm building it up by assembling the pieces of delicious cheeseburger into still delicious pieces of meat, yeah? Okay. Anyway, so anabolic processes build things up. Catabolic processes break things down. Got it? So you could match up anabolic with and catabolic with hydrolysis and dehydration synthesis correctly, couldn't you? Yeah? Okay. All right. So let's take another breather and